In this clip, we introduce equations that contain inequalities. We'll solve using reformulation until we get translational symmetry. And when we do, we'll be able to determine the range of the variable for the inequality. This equation is abstract. The variable does not have a tangible meaning. We have minus 3x plus 2 is less than 8. We have to find a range of that variable x. What we'll do is reformulate 8, the simpler side. We're going to leave the abstract side alone, work on the simpler side. I want to match this 2, so I'm going to subtract 2 from 8, and I'm going to add 2. Then I'll group these terms, unmatched terms, and do the evaluation. I get a 6. To match this coefficient, minus 3, I have to multiply by minus 3 and divide by minus 3. That's equivalent to multiplication by 1. Now when I do this division, I get minus 2. So now I have translational symmetry. However, we have to note that the coefficient is negative of the variable term. The coefficient is negative. That means that this sense of this inequality must be switched on the last step. So x is not less than minus 2, x is greater than minus 2. So the range of the variable will be on the number line from minus 2 to plus infinity. This inequality is three-sided, so to speak. It's like having an equation with 3 sides. 4x minus 2 is less than equal to x, is less equal to 3x plus 4. So one side, the middle side, and then the right side. The first thing I'm going to do is reformulate 4x. I want to match this. So I'm going to write it as 3x plus x. Bring that minus 2 down. Then this 3x, I need to reformulate it to x plus 2x in order to match that middle one. So I have 2x plus 4. Now, since I have x on 3 sides, I can subtract x from 3 sides. And when I do that, this becomes a 0. So we have 3x minus 2 is less equal to 0. That's one side of the equation. The other side is 0 less than equal to 2x plus 4. So what I'm going to do is work on this one first. 3x minus 2 less than 0. I'm going to rewrite 3x minus 2. And then I'm going to put in here on this side a plus 2 and a minus 2. Okay, to match this, minus 2. And then to match this coefficient, I need to multiply by 3 and divide by 3. And when I do that, I have x. This coefficient is positive, so this sense of this inequality stays the same. X is less than or equal to 2/3. Here it is right here. Now for the second one, 0 is less than or equal to 2x plus 4. Here it is written again. I'm going to add to this side the 0. I'm going to write plus 4 minus 4. And I wrote minus 4 as 2 times minus 2. Because this coefficient is easy, 2. And I can add 4. A minus 4 and a plus 4 is a 0. Now I have translational symmetry, and the coefficient of this variable term is positive, so x is greater than or equal to minus 2. Here it is, x greater than or equal to minus 2. So now I have both sides. So x is going to be greater equal to minus 2, less equal to 2/3. The range of the variable on the number line goes from minus 2 to plus 2/3. In this clip, we introduced rational equations. Rational equations are equations that contain abstract fractions. They're somewhat more difficult to solve because you can't tell by looking at the equation what the value of the variable will be that will solve it. We're going to use, again, reformulation, translational symmetry, and we'll get our solution. Here's the equation. X plus 3 divided by x plus 5 is equal to 2x minus 7 divided by 2x plus 11. We're going to reformulate. The first thing I'm going to do is match that 5 in the denominator. And I'm going to write x plus 5 minus 5 plus 3. I'm going to add a 0 to the numerator. That doesn't change the value of the numerator. Here, I want to match this plus 11. So I'm going to write plus 11 minus 11. That's a 0. And I'm going to add it to the numerator. Okay. Then my next step, I'm going to divide x plus 5 into x plus 5. I get a 1. And then this minus 5 plus 3 is a minus 2 divided by x plus 5. This is the remainder. When I divide this into that numerator, I get 1 plus the remainder. Here it is right here. Minus 2 over x plus 5. I'm going to divide 2x plus 11 into this numerator. When I divide into that, I get a 1. And then minus 11 minus 7 is minus 18 divided by this, 2x plus. Here's the 1, and this is the remainder. I would like the numerators to be equal, so I have to multiply by 1, and then substitute 9 over 9. And when I do that, 9 times minus 2 is minus 18. So that means these denominators must be equal. Remember, the number on this side is equal to the number on this side. So I'm going to multiply 9 times x. I get it right here. 9 times 5, 45. And then write this 2x plus 11. They must be equal, the two denominators. I'm going to formulate a symmetrical equation, translational symmetry, that when I add it to this equation, which is asymmetric, I get translational symmetry. So to match this 2x, I'm going to add a minus 7x to that 9x. I get 2x. I'll bring down the 45. I'll bring down this 2x. What do I have to add to 11 to get 45? 34. 34 and 11 is 45. But then I have to reformulate 34 so that I have a match of this coefficient. So what am I going to do? I'm going to multiply by minus 7, and I'm going to divide by minus 7. Now I have translational symmetry here. X must equal 34 over minus 7. I wrote it over here with the sign in front. And this is the unique solution, because when I added this to this asymmetric equation, I got translational symmetry, and that's the verification that this is the correct solution. In this clip, we have another rational equation. X plus 5 divided by 2 plus 1/2 equals 2x minus x minus 3 divided by 8. So this is the less complicated side of the equation that we'll reformulate. What we're going to do first, take this right-hand side, subtract it. Here it is. Here's the subtraction. and then add it to the left-hand side. There's the addition, there's the subtraction. That 1 can be added to that 5 to get a 6 because the denominators are the same. All right, so I added a 0. The next thing I'm going to do is group the unmatched terms. Notice that term, right-hand side equals right-hand side. There it is. So these are the unmatched terms. I want to separate them out, and I want to evaluate this. So here's the x plus 6, and 8 is the lowest common denominator, so I have to multiply this by 1, first term by 1, and I'm going to substitute 4 over 4 in order to get that 8 in the denominator. This term, I'm going to multiply by 1 and substitute 8 over 8. This term, I don't have to do anything. It already has the lowest common denominator. So 4x, 4 6s, 24, 4 2s, 8. 8 2s, 16. I'm going to bring the minus into the numerator and write a plus there. Change 2 signs. And then that's over 8. And this is already over 8. Now when I add this, 4x, next 5x, and then minus 16x, minus 11x. 24 minus 3 is 21. So when I evaluate it, I get 11x minus 11x plus 21 over 8. I'm going to rewrite this again in the next clip. So here's my evaluation again. Add this to this, the numerators. I get minus 11x plus 21 over 8. So here's the modified equation when I put it in the unmatched terms. And then I have partial symmetry. This is the odd term, must equal 0. When I find a value of x, it'll make this 0. That is the unique value, the unique solution. I'm going to reformulate the numerator. I have minus 11x. This coefficient is minus 11. I'm going to create a coefficient of plus 11, multiply times 21, and then divide also by 11. So that's equal to 0. This term must be equal to 0. Only the numerator we need work with. Consequently, from 1 to 1 matching, x is equal to 21 over 11. So I have the unique solution because when I substitute this back in here, I get a 0 for that term. And then I have translational symmetry, which means that is the unique solution.